So, DNS, Domain Name System, the world's largest distributed database. This is what helps us figure out the routing address of stuff we want to connect to on our network, on the internet at large. So if we're running a network and we're running DNS and we're putting records of our own systems into DNS, we need some sort of inventory of what devices we even have and what their addresses are. And for a lot of people on a lot of networks, even today, they're treating DHCP as a source of that inventory. Because obviously, DHCP, the Dynamic Host Configuration Protocol, knows everything about all the hosts. I mean, it has to know their IP addresses, that's part of it. But what about all the other metadata we need to put something into DNS accurately? Is DHCP really an accurate database or an inventory of what we have in our network? No, not at all. It's very inaccurate. There's a lot of problems with DHCP as a data source, and that's why I do not use DHCP as a source of addresses for DNS. So in this video, I'm going to talk about the problems I have with DHCP, why DHCP doesn't solve this problem anymore. Maybe it did at one point in the past, but with modern privacy extensions, it's just not something you can rely on. And what I use instead to manage the DNS on my networks. So if this is the problem you have on your networks, then come along in this adventure. Hey man, I need your help. Hey dude, can you wait? I'm just getting to the good part. I've been trying to become a coding wizard, but nothing is working. Can you help me? Well, what did you try already? Well, I've been trying these spells with ChatGPT, and I even got a black cat for good luck. Sounds like he needs boot.dev. Well, what's that? So boot.dev is an interactive site that helps teach you programming and other tech topics in a fun, easy to follow way. So recently I've been wanting to learn Golang. It's not a language I've really had to use yet. So I tried out their Golang course, and it was so much fun that pretty soon I was 69 courses in. So all of their lesson content is entirely free if you just want to read it and see what it's like. But for 21 euros a month, if you get a yearly subscription, then you get access to all of their interactive and gamifying features. So rewards for doing lessons on time, getting a streak, things like that. You can also compile all of your code in their platform and check that it's right, which I think is pretty cool. And also they've got a little bear wizard assistant that can help point you in the right direction if you're going wrong. Use my code APPLARD to get 25% off a yearly subscription. Link down in the description below, or QR code right here. So, to show how DHCP on modern networks is completely useless for providing inventory information, I set up a plain Wi-Fi network here with my MikroTik app, and I'm going to connect to it on my laptop here and log that connection in Wireshark. Now, this is something you're free to do yourself. You can install Wireshark on your laptop and capture your own interfaces super easily, which is what I'm doing here. So let's see what happens when my laptop does a DHCP request to this router here. Okay, so we got a number of different things going on, but the first thing we got is our DHCP discover here. So let's just follow this conversation. So we have the usual four-way handshake here. So my client sent a discover, the router sent an offer, my client then requested that offer and got an acknowledgement. So first off, my client, which currently doesn't have an address, sent a broadcast packet to a discover. So let's see what that looks like. So it's legacy IP version 4, it's UDP port 67, and it is Dynamic Host Configuration Protocol. Also notice here that it's called host configuration, not network configuration. It's not designed to configure the network, it's designed to provide information to the host, my laptop. So in here, it's a boot request. We've got a bunch of information that's currently 0 because we don't have an address yet. We got a client MAC address, which in this case says A6BD93-8B8E9C. So maybe I can identify my laptop by its MAC address, right? Well, not really. So all mobile devices now are going to randomize their MAC address, probably separately for each SSID. So this A6BD93, etc., that is a number that my laptop has generated for the connection to this specific network. So it's unique, but it doesn't mean anything. And we can't really rely on this staying consistent long term. Some operating systems now rotate it at a periodic interval for better privacy because they don't want to show off their real MAC address, which is essentially the hardware serial number of the unit. It's a truly unique ID that is tied to the specific hardware. So that's why we generate a random one each time. And that means for the DHCP server, it's essentially a random number. It doesn't identify this piece of hardware. It's just identifying the session. So we get on a bit. We've got some requests. So we have DHC message type discover, parameter list. So my laptop is asking for all of these parameters. It's asking for a subnet mask, a router, domain name server. It's opting for option 108, which is IPv6 mostly, etc. And then it's also providing a client identifier, which again is our fake MAC address. And it's providing a host name, which in this case is MacBook Air. I'd like to point out too that the host name of this laptop is not in fact MacBook Air. And so it's providing a sort of identifying information as a genericized host name. So for what I've seen, Apple devices provide this as just their model type. So MacBook Air, MacBook Pro, iPhone. And that'll give you a very rough identification for the device. But again, it's not something you can trust. So if I were to take my DHCP host names and put them straight into DNS, I would have a DNS record called macbookair.lan. And that would be completely useless to me because this is not MacBook Air. That's not its name. And if two people in my house have a MacBook Air, then DNS has to deal with conflicts. Either we end up with one record with two names, and then you randomly get connected to one of the MacBook Airs, or they just keep fighting for each other back and forth. Each time one of them requests a DHCP record, it overwrites the previous one. I have some IoT devices, for example, that all have the host name Espressif. That's the chip vendor they used. And so when they connect to DHCP, they just keep overwriting each other's DNS entry. Who's Espressif today? I don't know. It could be one of the 3 different IoT gadgets that are all doing the same job, but I don't know which one is which. And we have the end. So essentially what we got out of this is we got a random number from the client. We got a list of what the client wants, which in this case is not particularly useful to us. And we got a host name that is, again, randomized by the client. And so maybe you're thinking to yourself, well, maybe I don't actually need the host name of all of my client devices that are never receiving incoming connections in DNS. And that's fair. Maybe I just want all the IoT gadgets and all that other junk. So I did a PCAP of a real home lab network that I have access to, and I just captured DHCP traffic for like 6 or 8 hours. So let's take a look at some of the other devices on real networks and what they send over DHCP. So that's what this capture is here, and I've added a column here that shows the host name we got in the request. So in theory, this is what you'd be putting in DNS. You're going to be putting 6F06D78PAG97A98.LAN in your DNS server. Is that going to be useful information to you? How about 6B04A48PAG57A40.LAN? Does that sound good to you? So these are both security cameras, all 3 of these are. So they'd probably be useful to be able to connect to directly, but their host name in DNS is their serial number. Well, not exactly. It's like a serial model number kind of combination. So that's not a great source of the name. What we really want is like a name of the camera or something with some sort of naming scheme. And I guess we could go and edit the camera to put that information in DHCP, which we then put in DNS. But we could also just go straight to DNS and put it there instead. Manually, I guess, because that's part of provisioning the camera. And same with a lot of these. So like EAP235 wall COC93, that's an access point. Green Eye monitor, that one has a space in it, so that's not valid in DNS. ESP32C3 CDF918. What are you going to do if all of these go into DNS? This is not the names you want to be putting in DNS. This is a bunch of garbage. A couple of these are useful though. So I got a MacBook Pro, got an iPhone. Sync, so that's a car. This one is a virtual machine, and it has a name. So I guess that's useful, right? So essentially the root of the problem here is we are treating DHCP, which is a protocol designed to provide information from the network to the host, as some sort of inventory of all of the hosts that we have. And that is not what DHCP was designed for. Modern hosts don't treat it this way. They're going to provide you a lot of garbage in the name of privacy, randomization, and it's all information that any attacker on the network, first of all, they can see because it's broadcast, and second of all, they can spoof. So there's no guarantee that any of this information is accurate. If you're just taking this garbage data and putting it straight into DNS, that means your DNS is now full of garbage data as well. So I promise I'm not all doom and gloom in this video. So let's take a look at the simplest solution. Now, basically all home networks and small business networks, no matter what some people on the internet say, are essentially one big flat LAN. So everything is just speaking to each other over Ethernet. We're not doing VLAN segmentation or routing. Realistically, almost all networks, by count of networks, operate this way. Now, some are obviously engineered to be more complex, but for most people in that scenario, the solution you should be using for your local DNS is multicast DNS, mDNS. So going back to the fundamentals of what DNS is, it's helping us convert names of services, hosts, etc. into their address. And mDNS does exactly that very simply. So going back to this PCAP from earlier, this is all the mDNS traffic that my laptop was doing on my example LAN. So it's doing all kinds of stuff here. This is the same one where I connected to this MikroTik and I got the DHCP capture that said I was MacBook Air with random MAC address. So what did it actually show in mDNS in that same exact scenario? So it starts actually advertising its own reverse DNS. So this is IP6.ARPA. This is the reverse DNS. But somewhere down here, it should be, I think it's this one. It's advertising a whole bunch of services that it hosts. So these are all DNS service discovery. But at the very bottom, we've got this guy here. So we've got spaceship3.local, type quad A, class internet. And we've got our link local FE80 as well as our global unicast 2AOF. So my laptop here, Spaceship3, just advertised itself over mDNS as spaceship3.local, and it gave out all of its IP addresses. So someone who is directly connected on the same LAN can then communicate with this system by its local mDNS name, no server involved. So for example, if I come over here to my Proxmox system on a ping spaceship3.local, it's actually not able to resolve it, but we're close. So most Linux distros, some come pre-configured for mDNS and some don't. In the case of Debian that Proxmox is based on, it comes pre-configured, but it doesn't include the daemon that actually queries mDNS. So we got to install that. So I'm just going to apt install vahi daemon yes, and it should work. So it looks like it started it up automatically, and we should be good to go. So coming back to that ping, if I run that ping now, what do I get? It's like we found the IPv4 address, and we're good to go. I did find one bug here. Debian's default config restricts mDNS queries to only work over v4, so I got to fix that for v6 to work. In this case, I'm going to edit etc nsswitch.conf, and down here we're looking for hosts, and it has picked mDNS4 minimal, and we're going to change that to just mDNS minimal. Go ahead and save. So now if I ping, it's chosen to use the v6 address as its preference. And similarly, from my Mac, I can run that same ping, and here we go. I can ping my Proxmox server. So that means over here I should be able to go to that. And what do you know? I'm in. So between laptops, mobile devices, etc., all of them are going to do mDNS properly to begin with. If you have a Linux desktop, I would bet they're probably using systemd resolved, which is a bit of a better job than NSS mDNS that I'm using here. If you're on a Debian system like Proxmox, you have to install a vahi daemon, which again is not hard. And once you do that, mDNS just works like magic, like DNS was supposed to. So back on the doom and gloom for a little bit. I've heard people say they can't deploy IPv6 in their managed enterprise environment because DHCP v6 and IP address allocation with Slack doesn't give them the same visibility that they got with DHCP v4. And that's partially true and partially not. So what visibility do we get with the IPv6 version of address assignment compared to what we got in DHCP v4? So this is again my Wi-Fi capture, and I'm looking at ICMPv6 Internet Control Message Protocol. And we have a number of different types of messages here, but the most important ones we're going to get are going to be the router solicitation and the router advertisement. So I pick up this one. This is my laptop, and it's asking for, what is it asking? It is just saying router solicitation type 133, and that's it. There's no additional information. So my client is not sending any info whatsoever. And actually, it doesn't even have to send this router solicitation, because routers are supposed to periodically send their advertisement anyway. Just by sending a solicitation, it's just speeding up that process a little bit. And so then the router replies with a router advertisement, and this goes to everyone, not just my specific host. So this advertisement is valid for everyone. And it says here, let's see, so we have flags, we are medium preference, we are not managed, we have no other, we have a link layer address, that's the MAC address of the router, and we have a prefix information. So this is 2AOF B240 10167. It says it is on link. That means we can trust that this /64 is our subnet mask, essentially, and it is autonomous. So that means that we are allowed to auto-configure, and it has lifetime. So instead of generating a unique address and sending it back to my client, the router has said, here is the subnet, here is the subnet mask, assign yourself an address. And because we have 64 bits to work with, the client can either do it based on its MAC address, can do it randomly, however it wants. They're realistically not going to collide, and even if they did, we have duplicate address discovery. So now the host has chosen one or more addresses from the prefix the router gave it on its own. There's no mechanism here to feed that allocation back to the network. And we don't need it, because the network can discover that these addresses are in use by the fact that traffic is flowing over them. And so this is where it seems like a lot of sort of enterprise network people get really hung up. They're like, back in DHCP v4, we had the logs of a DHCP server. They told us every MAC address on our network and every IP address on our network. So now in IPv6, we lost that source of logging. We no longer have a log of what MAC address corresponds to what IP address. But you know what? Those logs were entirely useless before. All the MAC addresses are random, they're all spoofed. None of these hosts are giving you their real MAC address, realistically. So what were you going to do with that information anyway? You're going to say this IP address is in use and it's attached to a random MAC address. I have no idea what it is. So this is the other feature of DHCP v4 that I think a lot of people were hung up on and using it sort of improperly. DHCP was never intended to be a database or an inventory of all of the devices on your network. Now that is still something that's very useful to have, especially if you're looking at security or auditing or things like that. You want to say, what host was this bit of traffic I saw? But DHCP is not a reliable source of that data, and you shouldn't be trusting it with that sort of inventory. So if you're in a managed environment where you control all of the hosts, you have some sort of agent running on it, you might have Active Directory in a Windows environment, you might have something else, you know what all of your hosts are because you have a database of them. You can use a tool like Netbox to keep track of all of your hosts. That will tell you what their IP addresses are if you have an agent forwarding data back there, if you're renewing certs on those certificates, stuff like that. You have other ways of keeping track of this information in a much more accurate way using your true device inventory, as opposed to claiming that DHCP is your inventory. But even in a managed environment, we still need to get data into DNS. So one option is to periodically dump your inventory database and make that a host file. There's plugins for Netbox, for example, that will do bind9 style zone transfer. That's an option. I've seen plugin for Core DNS that will just directly query Netbox every time a DNS query comes in. Those are some options you have to reliably publish your DNS information from your inventory source like Netbox. But another approach that I'm going to take here, which I think is perfectly valid for medium-sized networks, is to just do this via automation. So every time I create a host that needs its name in DNS, that's basically a server. So I don't need my laptop in DNS. I don't care what its IP address is. But all of my servers, my virtual machines, my containers, I want to get those guys in DNS. So every time I create one, I need to put it in DNS as part of that provisioning step. And for me, that means Ansible. So here's a playbook I wrote that just provisions a new Proxmox VM and registers in DNS. So I've got some templates here. What is going to be the template I'm going to clone from? I'm going to start by cloning an existing CloudInit template. Then I maybe want to give it a name, etc. Maybe we'll call this guy testing. I had some instructions to update the core's memory, but I took those out just for this demo. And what network is he on? So in this case, he's on 2AOF B240 10167. So start by getting the next available VM ID from Proxmox. Then I clone that template. So I'm taking an existing VM, which If you followed me for a while, I made a video on CloudNet templates, probably up here, and I still use that to this day. So all of the major distros provide pre-built CloudNet images ready to go. I import those into Proxmox, and those are the basis for my virtual machines going forward from there. So I'm starting from this CloudNet template that came directly from Debian, and I'm cloning it. So there's the clone step, and then we just kind of keep querying the API until that is done. And then at this point I could set up the VM with anything pre-boot, but I want to put it in DNS. So to do that, I get the VM's config from Proxmox, and that includes a line like this that says net0 virt.io MAC address, and then what bridge it's on. And in IPv6, most of these server operating systems are using EUI64, so it's using the MAC address to compute the IPv6 address directly. So most clients are going to use stable privacy, where they're going to totally randomly generate it. But for servers, using EUI64 is an easy shortcut. It means I don't have to actually figure out what the IP address is in the VM. I can just know that given the VM's MAC address, it must be this IP address. And I do just that. I've got this awful bit of Jinja code that figures out what the IP address was given the MAC address, and I show it. And then I'm using Technidium. Again, video on my Technidium. I really love Technidium DNS server. I'm happy with it. So I'm just doing a post to Technidium to add the new host name and the new IP address. So I just run this playbook here. I should end up with a new VM in Proxmox. So it allocated 723. So it's taking a couple seconds to clone. There we go. So I got them at IP of 2001, 9AA, blah, 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 blah. BE2411FF FE35 1B17. So over here in Proxmox, looks like that VM has been created. So let's go ahead and start it up and see what its IP address is. So it's of course going to install updates and do all kinds of stuff on its first boot. What do you know? Here's our IP address. BE2411FF FE35 1B17. Is that what we figured out and put in Technidium? Yes, it is. No DHCP involved, no IPv4 involved at all. So as part of this provisioning process, I've taken the important information, which is the address of this server, and put it in the DMS via automation. I didn't have to rely on DHCP hacks. This is not susceptible to an attacker like forging this host name or MAC address, for example. If an attacker on my network were to do a DHCP request with the host name or MAC address of one of my servers, it could, for example, change its location in DNS to point to the attacker now. But because I've done this via automation, it's not susceptible to that. And of course, now that I put in DNS, I can ping it. So I promised you guys 3 different options, and I've only given you 2 so far. So now I got real dynamic DNS with NS Update. So given how widespread like HTTP-based dynamic DNS is, where you're querying some service on the internet that's doing dynamic DNS for you, there's actually a standard for this called RFC 2136 or NS Update. So this is a DNS command called update that lets clients update records in the DNS server. Now this runs over the regular DNS protocol, so it's not HTTP or anything like that, and it's secured using the same security used for zone transfers, TSIGs. And also, to do this securely, we need to generate a new TSIG shared secret for every single host we're going to update. That way, if one host is compromised, their shared secret can only compromise their own record in DNS, not everyone else's. But that's not that big of a hill to overcome, so let's set up our new testing server we just provisioned with Ansible to use dynamic DNS instead. I've actually got all the commands you need on my blog, so go ahead and check there for the latest ones. I'm just going to sort of speed run this. So over here in Technidium, I'm going to go to Settings, TSIG. I'm going to hit Add. I'm going to use HMAC SHA-256. I'm not going to put anything for a shared secret. I'm going to name it Host Testing. So this name is important. As soon as I hit Save, it'll generate me a new shared secret, which I was in plain text here, so it's not like that secret, but we just have to copy and paste the name and that shared secret onto our host. So over on the host here, I'm going to edit etc.tsig.key. So this name must match what we had in Technidium. We're going to say algorithm is HMAC SHA-256, and secret, we're going to paste in our secret with a semicolon. So I'm using a command line utility here called NS Update. This is part of bind9 DNS util, so we got to install that package. And on its own, it does not exactly do like what we would call DNS updating, in that it doesn't actually query any IP address or change any record. It's just a tool that lets us interact with the DNS update protocol. So we need to give it a bunch of commands based on what addresses we're going to delete, what we're going to add, and what those IP addresses are. And it's a little bit complex, so I wrote a bash script that queries the local addresses in the local system and generates this list of commands for NSUpdate, pipes it to NSUpdate, does all that. So here's what the script looks like. So we start with the host name, which you could obviously change, but I'm just going to use host name. And then our fully qualified domain name, which is just going to be, in my case, at appler.fi. Obviously, you'd change that. So then each of these echo lines is adding a new command to NSUpdate. So I'm saying what the server is. This is the server we're going to push the update to. What is the zone we're going to push the update to. Then we're going to delete all of the existing records for this existing fully qualified domain name. And then go through our v4 and our v6 address and add them back in. So hostname-i will give us the IP addresses in the system. We throw out any v6 and any loopback, and then we add those as A records. And then similarly down here for the v6, we throw out anything that's not v6. We throw out loopback and we throw out link local, and we add that as v6 addresses. So by now we should have a whole string of commands: server, zone, update, 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 and then send, which does one transaction with all of this in it. And then we send that to NSUpdate and tell it to use our tsig.key. So I put that script in user local bin DDNS, and don't forget to make it executable. So now if I run this script just once, it should do the update, and we should see it in Technetium. Oh, I forgot to install NSUpdate. So I need bind9 DNS utils. Now it should work. Now it says refused. Oh. So in this case, Technetium refused the update because it didn't know that this tsig is allowed to update certain records. So we have to go add that access control information in Technetium. So from the zone in Technetium, we can go to zone options here, and then dynamic updates, and it defaults to deny. And so we want to allow this to certain people. So I use specified ACL so that anyone on my network, so these are my IP address ranges, can access this. And then down here we have to add a security policy for each tsig we want to allow. So I'll add this host testing. I'm going to specifically restrict it to its own name, which is testing.php.appler.fi, and restrict it to only A and quad A records. So we'll save that. So I can run this again, and this time I got no output, so I guess it worked. And looking at Technetium, so if I look for testing, I got an A record and I got a quad A, and they were last modified a few seconds ago. So it says here, via dynamic updates, using key host testing from the IP address that did the update. So now at this point, we just got to call that script. If you're using like Network Manager or Network D or IF up down or something like that, you can put this script in your Network Manager so that when the interface comes up, you could wait like 20 seconds or something and then call DDNS, and then it'll update dynamic DNS. That's how you should do it, but the simple way is to run a systemd unit that just does this every hour or something. And so if you want to do that, the easy way, I got a script on my blog post that you can follow. So which of my options is best for your network? If you're a home network or a small business network, I'll get to what that means in a sec, multicast DNS was literally made for you. So solutions like Matter, the home automation standard, AirPlay, AirPrint, a bunch of things like that rely on multicast DNS and DNS service discovery, which is a related protocol, and they make your life way easier. So once you start segmenting your network down, micro-segmenting a VLAN for every device, that kind of stuff, you break multicast DNS and DNS service discovery, and that makes your life a whole lot harder for no good reason. So in the real world, most devices like laptops, phones, that kind of stuff, they're used to living on the internet bare. Because if you're connected to a cellular network, you're connected essentially directly to the internet. You're going through CGNet and IPv4, but that's it. There's no protection from your cell phone company. So these devices are already pretty well hardened against network-based attacks, and adding VLAN segmentation is not going to help them very much. Now what is going to help is when you start bringing servers into the mix. So if you're a business that's big enough to have any servers either on-prem or in the cloud, but not like software as a service, like your own actual servers, or if you're running servers in a home lab, then you start doing more segmentation because it's actually benefiting you. So in that case, you probably want to start running your own DNS server. I love Technetium, I've already mentioned that. And one of the two other updates I mentioned, either using Ansible to push configs automatically, or using DNS, or somehow generating your DNS from your inventory, but managing a real inventory of your devices and not relying on DHCP and all of its junk is the approach you should be taking. As for IPv6, I know some people claim that they must have DHCP and IPv6 because otherwise they don't know what's going on. With IPv4, you don't know what's going on anyway. So MAC addresses can be faked really easily. There's nothing stopping an attacker from just using a random MAC address or even using a random IP address. I mean, they don't have to go through DHCP if they don't want to. Static addresses are a thing. So just because someone did a DHCP request doesn't guarantee all that information is accurate or real or that device even exists. I would love for you guys to argue about it in the comments. I love the engagement I get for that. So please argue all day about what you do with your DHCP and DNS systems. I would love to hear about that. If you want to discuss more topics, I have a Discord server link down below for that. If you guys want to become coders, you can take my code AppleArt for 25% off a yearly subscription to boot.dev. Link down in the description below for that as well. And I guess I'll see you guys. Oh, my merch, yeah. If you want a t-shirt, like the fine t-shirt I have here, Home Lab, your own personal data center. I sell these. It's a great way to support the channel. See my link down to my Ko-fi in the description for that. And then I guess I'll see you guys on the next adventure.